Hi Year 8. In the second lesson, you'll be able to state the unit for potential difference and explain how to measure it. You'll be able to state what happens to the potential difference in a series circuit as we add more bulbs. You'll be able to explain what potential difference means. And as a Wally task, some of you might be able to calculate the power of a component. So as a starter, pause the video and answer these questions. Did you get currents to flow of charge? You can increase the potential difference, that will increase the current, or you can reduce the resistance of the components like the bulb. The dimmer switch is a variable resistor. Turning the switch increases the resistance of the circuit and the current decreases as the bulbs become dimmer. Just before we start looking at voltage in a series circuit, I just want to remind you about what happens to current from the last lesson. So we know the current at position 1 is 0.3 amps, but will the current be the same or different on the other side of the bulb? So measuring current on the other side of the bulb, we still get 0.30 amps, which shows that current is not used up as you go around the circuit. It just carries the energy. Whatever current flows out, flows around the circuit and flows back to the battery. So potential difference is like an electrical push the cell gives to the current, so it pushes the charge around the circuit, and it's measured in volts. To measure the potential difference, we need to connect a voltmeter in parallel across the power supply, so that will measure the voltage across the power supply. To measure the voltage across the bulb, we need to connect the voltmeter in parallel across the bulb. Remember, the ammeter to measure current is connected in series. So different cells we know produce different potential differences. You can get 1.5 volts, you can get 9 volts, and the bigger the potential difference supplied by the cell, the bigger the current that flows because it pushes the electrons around faster. Our first activity is going to investigate what happens to potential difference around the circuit as we add more bulbs. We're going to start with one bulb and measure the current and the voltage with a 6-volt power supply. We're then going to connect 2 bulbs and measure the voltage across each and the current again. And then finally, we're going to connect 3 bulbs together in series and measure the voltage across each and the current. And for a Wally task, power is the electrical energy a bulb gains per second. So power equals potential difference times current. So after each measurement, you could pause the video and calculate the power and compare it to the brightness of the bulbs. So with a voltage of 6 volts, we've got a current of 0.3 amps flowing around the circuit. So putting a voltmeter across the bulb gives us a voltage of 5.97 volts, which is really 6 volts because these meters are just too accurate. You'll notice that's the same as the power supply voltage. So adding another identical bulb in series causes the current to drop to 0.2 amps because the total resistance of the circuit has gone up as we've added another bulb, and you'll notice the brightness has gone down. Measuring the voltage across the bulbs, we find the first bulb has 3 volts across it, and the second bulb also has 3 volts across it. You'll notice they share equally the 6 volts. Finally, adding a third identical bulb in series, the current reduces to 0.17 amps as the resistance has gone up again. The voltage across the first bulb is 2, the second one is also 2, and the third one is also 2. So you can see that they share the voltage equally again. So the Wally task was to work out the power of each bulb, and power is potential difference times current. So for the first one, it is 6 times 0.3, which is 1.8 watts. The second one, the power was 3 volts for each bulb times 0.2, so that gives you only 0.6 watts. So you can see the power of the bulb and the brightness of the bulb has dropped hugely. Finally, the last one, the power of each bulb would be 2 volts times 0.17 amps, which is only 0.34 watts. So you can see the brightness drops dramatically as you add more bulbs in series. So in this activity, we can look at what happens when we put bulbs of different resistances in series to see how they share the voltage. We've got a green bulb with 94 ohms and a red bulb with 28 ohms. They're called red and green because of the painted dots on them, so we can identify which is which. So which takes the largest share of potential difference voltage and so the electrical energy from the power supply? Will it be the red or the green bulb? So you can see the green bulb with a higher resistance takes a much larger share of the voltage, so they don't share it equally. So what is potential difference? They're not identical resistors. Yes, potential difference for a power supply gives the charges energy. It pushes them round. But potential difference is the electrical energy gained when a charge goes through the power supply or lost when the charge goes through bulbs. Yes, potential difference voltage of a power supply gives the charges energy to push them round, but we need to know that in a bit more detail. So the definition of potential difference is the electrical energy gained or lost for each charge passing through an electrical device. So let's use another model to help explain this. Here we have charges. These students are in a circle, a series circuit, and they are a charge. And the charges are equally distributed throughout the wire. Here we've got a battery, and it's a 3-volt battery. And here we've got suites, and each suite represents 1 joule of electrical energy. And we've got a switch here. And at this side, we have a bulb. So when the charge goes through the battery, they gain 3 suites each, because the battery gives 3 joules per charge. So you can see now we've got each of those charges that have gone through the battery, each of those students have 3 joules, 3 suites each. So the potential difference here is 3 volts because each charge is carrying 3 joules of energy. They lose that energy, that electrical energy, which is converted into heat and light in the bulb here. And so here, they're not carrying any electrical energy, so the potential here is 0 volts, because that's 0 joules per charge. So you can see the potential difference across the battery. If this end is 0 and this end is 3, the difference is 3 volts. So how much electrical energy must the bulb gain? It's the only component in the circuit. Well, it must also gain 3 joules per coulomb because it's not having to share that energy with any other component. So let's now double the number of cells. So if we double the cells, how much energy will each charge gain, or how many suites will each charge gain? Yes, you're right, they're going to go through 2 cells, and so they're going to gain 6 joules per coulomb, 6 suites. So what's the potential there? It's going to be 6. And on the other side, the potential is going to be 0. So what will be the potential difference across the bulb? You're right, it's going to be 6 volts. So finally, let's use this model to see what happens when we add bulbs in series. So again, we've got 6 volts altogether, like we have in our experiment, and each charge is carrying 6 joules of energy. How much energy will each bulb gain if they've got identical resistance? You're right, they will share the energy equally. So this bulb will gain 3 joules of energy, and there's 3 joules left for this bulb. So let's have a look at the potential differences around the circuit. The potential difference there, of course, will be 6. In the middle there is going to be, that's right, 3. So the voltage across there is going to be the difference in potential, the potential difference, which is 3. The potential difference there is 0. So again, the potential difference across this bulb is going to be 3 volts. It's 3 there and 0 there. So first plenary, read through these and work out what goes in each gap. The start of lots of the letters are there for you. So we have potential difference is measured by a voltmeter connected in parallel or across the component. The potential difference across the component tells us how much electrical energy is gained or lost when a charge passes through it. The second plenary, have a look at that, read through it and work out what your answers are going to be. Pause the video. So current is the same around a series circuit. This is because the charge has only one loop to flow around. The potential difference, which is voltage of the power supply, is shared between the components in the circuit. The potential differences around the circuit add up to the supply voltage. As you add more bulbs in series, the current decreases as the total resistance of all the bulbs increases. As you add more bulbs, the potential difference across each bulb decreases as the brightness reduces. And finally, if one bulb blows, the others will go out because there will be no path for the current to now flow. So let's check our learning outcomes. You should now be able to state the unit of potential difference and how we measure it with a voltmeter in parallel. You should be able to state what happens to the potential difference in a series circuit. It is shared, and as you go around the circuit, the voltages add up to the supply voltage. You should be able to explain what potential difference means. It's the electrical energy gained by a charge going through a battery, or the electrical energy lost when the charge goes through a bulb or component. And finally, you might be able to calculate the power of the component using voltage times current. What you now need to do is to go and finish off the worksheet on this lesson. And I will talk to you again next week. Bye for now.